I don't think I ever told you about when my costume was down in what we used to call the basement, which is now the storeroom for the dining hall. We used to have 4 math classrooms down there. And then we lost them. But anyway, no windows. We were literally down in a dungeon. And so one year, I was always complaining about if they came in soaking wet, I knew it was raining, but other than that, I had no idea what the weather was like. And so some of the kids made this like cardboard window, and it had different pull-down things. So they would come in, and if it was sunny out, they'd pull down the sunny one, and then if it was raining, they'd pull down the rain. It was really cool. I don't know what happened to it. It disappeared when I got sick, so I don't know what happened to it, but it was really, really cool. Now I have my own windows. So that's good. All right, I want to look at, on the 3.2 homework, I will just talk about the first one. So theta is an angle in standard position. So what that means is, it's like this, okay? Theta is an angle in standard position. The terminal side contains the point -3/4. So this is the point -3/4. So my angle actually looks like this, okay? Now it says, find the sine and the tangent of that angle. Now here is what has shown up on some papers. Some people said the sine is 4 and the tangent is -4/3. Now I am in complete agreement with this one. But this one is off base. Now, I understand where that's coming from because we've talked about that sine is y. But wait a minute. When is sine exactly y in a unit circle? If you drew a circle through that point, is that radius 1? If we are over 3 and up 4, that radius is not 1. That radius is 5. So in other words, x is -3, y is 4, and the radius is 5. What's our definition of sine? Our real definition? Sine is y over r, opposite over hypotenuse. So sine should be 4/5. Now, if you want to put this in the unit circle, you can by dividing everything by 5. Now it's a unit circle, and now your point is -3/5, 4/5. So now can you use y as your sine? Yes. But sine is a ratio of y to r. Okay? All right, I just want to fix that one. I think that should take care of things for you. Okay. All right. Now, I want you to get out your last things at the end of this worksheet, the 3.1 worksheet packet. The very last problem, the Ferris wheel problem. It looks like a Ferris wheel, but it's a prize wheel for a game show. Okay, so we have a packet called Worksheet A 3.1. The packet. We have done all of it now, pretty much, except the last problem. Some of you think I'm dwelling on this too much, but it's a question probably on the actual, so that is important. All right, so go ahead, read the problem. Sylvia, are you reading your problem? Started writing some points. What did you come up with? What are some points you come up with? 0:15. How does that sound, everybody? 0:15. Now there's going to be another point that we were going around and around and around. There's going to be another point where it's back at 15 again, and that will be 1 revolution. 0.25, she says. Now, why does she say 0.25? Because the problem tells us that 4 revolutions in 1 second. So doesn't it mean that we do 1 revolution in 1/4 of a second? Remember, your ordered pairs are seconds, inches, or whatever it is. You agree? Okay. So, okay, great. Now, if it's its lowest point here, then halfway through, it should be at its highest point. So what will that be? 0.125? Might be easier. I'm going to use fractions. So this would be 1/4 and this would be 1/8. If you know all your decimals, that's fine, but with no calculator, I'm just going to use a fraction. Now, how high is it at its highest point? Let's see, what do I know? Why do we think it's 75? Because the diameter of the wheel is 60. So it's 60 above where it was. Okay, so this is at the bottom, this is at the top. So halfway, it's straight across. So that'll be half of that, 1/16. What will that be? 45. You can do that one of 2 ways. You can either think about it from the figure itself. The radius is 30, so toward the bottom of 30. Or you can average these two and find the midpoint, right? Right, where else is it 45? When it spins around to the other side, it's going to be at 45, and that will be at 3/16. Do those numbers make sense to everybody? And you know you could continue this list because that wheel is just going around and around and around. Now let's see if we can make our points work here though. I don't think so. Wouldn't this have to be 0:15 over here? Low point. And then this will be 1/4 15, so I can put down. This one, I don't have it marked, but wouldn't this one be 1/16/45? So my first marked one is going to be 1/8/75. Are you following along here, everyone? This one will be 3/16/45. And I got that one. Now I need 2 more. Okay, so what's going to come after 1/4, Charlie? 5/16. Look, kids, you have 1/16, 2/16, 3, 4, 5. just 3/8. So at 5/16, I'm at 45. And at 3/8, I'm at 7. Is that okay to everybody? Now we got a little bit different questions asked here. Some vocabulary that we have talked about and some vocabulary that we haven't. So let's just talk about it. Period. You know what a period is. What is the period of this curve? One time around. 1/4. If you're going to put a unit on it, it's 1/4 seconds. A period is 1/4 seconds. Every 1/4 second, it goes once around. Everything repeats. Frequency is a word that you may not have heard before. Frequency is simply the reciprocal of the period. The reciprocal of the period. The frequency tells you how many cycles you make in one unit. Okay? So if you do one cycle every 1/4 second, then you do 4 cycles in 1 second. That's what frequency is. It's the reciprocal of the period. So 4 seconds. Amplitude is the height of the hills. It's the height of the curve from the midline. So this is the amplitude right here. That is the amplitude. This is the amplitude. Amplitude is a positive number. But the height of the hill, the depth of the valley, that's your amplitude. So in this case, the amplitude is 30. And that makes perfectly good sense because what is the radius of my thing? And we're up 30 and down 30, right? Midline, well that's obvious. Midline is, look. And so our midline is 45. We will be writing equations for that curve. That's our next step. And we will need all of those numbers. So period. How long does it take me to get from here to here? That's my period. Frequency is the reciprocal of that number. Amplitude is the height of the hills. Midline is the middle. All right. Find 2 intervals for which this graph is both decreasing and concave up. Decreasing and concave up. Find 2 intervals. G to J. So the interval from 3/16 to 1/4 is decreasing and concave up. Can you find another one? Decreasing and concave up? No. Well, you have to make one. You don't have one, you have to make one. So, I don't know, could we put one out here? Could we have this one right here? So we need to find these 2 points. That's easy. If this is 6/16, then won't this one be 7/16? And this one will be 8/16, which is a 1/2. So the interval from 7/16 to 1/2. Now, are there other ones that we could come up with? Yes. And what would they all have in common? Remember, what's the period? The period is 1/4. So if this is 3/16, doesn't it make sense that this is 4/16 later? And the next one will be 4/16 later, and so on. This is a sine or a cosine, depending on which section you look at. If we go from here to here, decreasing concave down, decreasing concave up, increasing concave up. So in the sine curve or the cosine, you have 4 sections, and each section is different in terms of how it's viewed. Okay, all right, put that away. Everybody still with me? Have we lost anyone? All right, let's look in worksheet, the practice 3.2 packet. Practice 3.2 packet. Got it? Find it? Practice 3.2. Turn to page 3. We're in practice 3.2 packet. We're on page 3, and we're looking at problem number 1. The figure shows a circle centered at the origin, angle theta, standard position, terminal ray, point P. Measure of angle theta is pi over 3. Does that make sense to you? Okay, so what are the measures of Q, R, and S? Boom, boom, boom. What are they? Q is 2 pi over 3. R is 4 pi over 3, and S is 5 pi over 3. Number 2. Now our angle is pi over 6. So what's Q? 5 pi over 6. What's R? 7 pi over 6. And S is 11 pi over 6. You got it. Go to the back of that page. Back of page 3. We got a circle, amazing. There was 4. This time our angle is pi over 4. So what are Q, R, and S? 3 pi over 4, 5 pi over 4, and 7 pi over 4. Good? All right. Number 4, 5, and 6 on that page. So back at page 3, 4, 5, and 6. See if you can figure it out. I'll see you guys on Monday. Remember, Tuesday is math week. Do not forget. Number 4. I don't know anything about my angle except it's in quadrant 2. There's only one quadrant 2 angle in that list, you guys. Which one is it? 85 pi over 6. Right. Number 5, I am in quadrant 3. The only quadrant 3 angle in there is C. 5 pi over 4. 3 pi over 2 is not in a quadrant. 3 pi over 2 is on a quadrant line. it is called quadrantal angle. It's not in a quadrant. And then number 6, I gotta do quadrant 4, so that would have to be 5 pi over 3. Okay, good. Alright, put that away. Alright, I just gave you a new packet for 3.3, some new stuff from 3.3. Notice the angles on, I didn't number these pages, dang it, you're on 2 of them. On page 1, the front of page 1, notice, look at all the angles. What about all those angles? Aren't they all quadrantal on an axis? So you should not struggle at all with this page. Your angles are all right here on an axis. So if you remember where your angles are, then you should have no problem at all answering these questions. What is the sign of pi? 0. Because pi's over here. The sign is y. 0. What's the cosine of 0? 1. What's the sine of pi over 2? 1. All right, fill in the rest of each other. This won't take very long. And I'll do it. Cosine 3 pi over 2 is 0. Cosine pi over 2 is 0. Cosine pi is -1. Good. Sine 3 pi over 2, -1. Cosine 2 pi, 1. And sine 0. Sine 0 is 0. And sine 2 pi is 0. Beautiful. All right. Now, for this page, the back of page 1, remember that cosine theta equals x over r. So if you are finding x, you need your coordinates, x will be r cosine theta, and y will be r sine theta. So your ordered pair, x, y, is r cosine, r sine. This is x, this is y, so that's your ordered pair. So for problem number 1, we're looking at point Q. Tell me which of those answers matches up with point Q. R is 3. We just got to get the right angle. So point Q would be what angle? 4 pi over 3. So the answer is B. All right, same thing with number 2. The radius is 9, we got that. We're doing point Q. So point Q is 5 pi over 4. So D. All right, do 3 and 4. Alright, 4 is a little wild. How about 3? What'd you get for 3? C, 11 pi over 6? Everybody okay with that? Alright, let's look at number 4. That is kind of, I didn't realize how tricky one was in there. Let's look at that one, see if we can figure that out. So we know our radius is 15. And we're talking about this angle right here, Q again, right? So just forget all this stuff on there. What can you tell me about Q? What angle is Q? 7 pi over 4. And I know that for point Q, 7 pi over 4, that would be positive root 2 over 2, negative root 2 over 2. Would you agree with that? Now the problem is, he didn't give me 7 pi over 4 as an option. But there's a lot of pi over 4s in my options. So let's go up and look at pi over 4. What can you tell me about the ordered pair on my unit circle for pi over 4? Root 2 over 2, root 2 over 2. So would you agree that it's exactly the same except the y is negative? So this one would be 15 cosine pi over 4, comma, 15 sine pi over 4. That would be this guy right here. Well, this is the same thing, only the second one's negative. So wouldn't this one be 15 cosine pi over 4, negative 15 sine pi over 4? Does that make sense to you? Since all I need to do is make y negative, is that an option, I hope? Yes, C. Let's see if we really get this. Look at answer D. C is the correct answer. Look at answer D. What would that be describing? That would be describing point P, because aren't they both negative over there? All right. Next time I see you, we're going to review one more day. At the very beginning of the period, we're going to take a little quiz, short little quiz, and guess what it's going to look like? It's going to look like the back of this page. Now, there aren't going to be that many problems because I don't want to grade that many and I don't want to take that much time for you to take it. But by Monday, or by Tuesday, next class, Tuesday, you need to know your unit circle well enough to answer these questions, okay? So let's practice a few right now. I don't want to practice all of them. Let's do 13 through 18. We'll just right now see if you can do 13 through 18, and we'll check those. Then, after that quiz on Tuesday, we'll review some more, and then our quiz will be our next class after that. Is that what it say? I don't know. Okay? over 2? Don't you love your pile of 4s? They're all root 2 over 2. All you gotta do is which one right there. So yes, positive root 2 over 2. How about 14? 1/2. 15. Negative root 3 over 2. 16. Positive root 3 over 2. 17. 1/2. And 18. Negative root 2 over 2. Alright, so you got the rest of the problems on that page to practice on. Charlie?
I just had a question on number 11 on that page.
Yeah, remember how negative angles work? Negative angles go this way, so negative pi over 2 is right here. That's the point 0, negative 1. So cosine is 0, sine is negative 1. Thank you for looking at all the problems. Okay? Alright, so next time we'll take our quiz and review a little bit more, and then we'll have a big quiz over all this. I'm going to hand back the last quiz right now. So you can start looking at these. I will be collecting these back up. Be honest, how many of you did those last problems without your unit circle? That you figured it out as you went? Okay. If you did not raise your hand, then you have your work cut out for you this weekend, right? We're going to get that unit circle. So one thing that we need to be really careful